In every workshop, whether it's a professional garage, a construction site, or a cluttered corner of someone's home, there are tools that come and go. Some tools look impressive when they're brand new, but start falling apart after a few months of real work. Others promise power, precision, and innovation, yet the moment they face dust, vibration, or daily abuse, their weaknesses start to show. But every experienced mechanic, carpenter, or technician eventually learns that a few tools stand apart from the rest. These are the tools that seem almost immune to time. They survive drops from ladders, years of heavy use, overheating motors, and conditions that would destroy cheaper equipment. In many workshops around the world, there are power tools that have been running for decades, older than some of the people using them, and they still work like the day they were bought. These machines are not just tools anymore. They become part of the identity of the workshop itself. The reason some power tools last so long comes down to a combination of engineering philosophy and design simplicity. Many of the most durable tools were created in an era before companies began chasing lightweight materials and aggressive cost-cutting. Manufacturers built them with thick metal housings, over-engineered motors, and components designed to handle far more stress than the average job would ever produce. Instead of relying heavily on fragile electronics or complicated digital systems, these tools were built around simple mechanical reliability. A strong motor, solid bearings, and durable gearing meant that even if the tool was used every day for years, it would continue functioning with minimal maintenance. For mechanics who rely on their tools to earn a living, this kind of reliability is priceless. When a tool refuses to die, it becomes something you trust without hesitation. One of the most famous examples of this kind of durability is the classic angle grinder. On construction sites and in metalworking shops, angle grinders are exposed to some of the harshest conditions imaginable. They cut through steel, grind welds, remove rust, and polish surfaces, all while throwing sparks and metal dust into the air. Despite this brutal environment, certain grinders seem to run almost forever. Their motors scream at thousands of revolutions per minute, yet year after year they continue working with the same raw power. Many mechanics can recall a specific grinder in their shop that has survived decades of punishment. Sometimes the paint has worn away from the handle, the cord has been replaced multiple times, and the guard shows the scars of countless jobs. But the motor inside keeps spinning like it refuses to accept the concept of failure. Another power tool with a reputation for near immortality is the corded drill. Long before battery technology improved enough to support high-performance cordless tools, corded drills dominated workshops. These machines were built with extremely robust motors designed to run continuously for long periods without overheating. Because they were connected directly to power, there was no need to compromise performance for battery efficiency. The result was a drill that could deliver consistent torque, hour after hour. Many older corded drills are still in use today, sometimes passed down from one generation of craftsmen to the next. It's not uncommon to find a drill from the 1980s or even earlier still operating perfectly after thousands of hours of work. The simplicity of their design means that even if something eventually wears out, it can often be repaired easily with basic replacement parts. Reciprocating saws also belong in the category of tools that refuse to die. These aggressive cutting machines are used to slice through wood, nails, pipes, and sometimes even entire walls during demolition work. The violent back-and-forth motion of the blade creates tremendous vibration and mechanical stress, yet certain models continue running year after year. Their durability comes from heavy internal gearing and powerful motors capable of absorbing that constant shock. Mechanics often describe these saws as indestructible because they keep functioning even after conditions that would destroy other equipment. It's not unusual to see a reciprocating saw covered in drywall dust and scratches from years of demolition work. Yet the trigger is pulled, and the blade immediately starts pounding back and forth like nothing ever happened. Impact wrenches represent another category of power tools that earn legendary reputations in garages and repair shops. Anyone who has worked on vehicles knows how stubborn rusted bolts can become. Removing them sometimes requires enormous bursts of torque that ordinary tools simply can't deliver. Impact wrenches solve this problem using a hammering mechanism inside the tool that repeatedly strikes the drive shaft with powerful rotational impacts. This design produces incredible torque while protecting the motor from excessive strain. Because of this unique mechanism, Many high-quality impact wrenches can operate for years under heavy use without significant wear. In automotive workshops where hundreds of bolts are removed every day, a reliable impact wrench quickly becomes one of the most valued tools in the entire shop. The final category of tools that seem almost impossible to kill is the circular saw. Used heavily in construction and carpentry, circular saws face constant stress while cutting through thick lumber, plywood, and engineered materials. A well-built circular saw relies on a powerful motor combined with a strong gearbox and blade housing capable of handling continuous load. When these components are properly engineered, the tool can survive thousands of cuts without losing performance. Many contractors still rely on older circular saws that have been part of their toolkit for decades. The blades may have been replaced hundreds of times, but the saw itself continues operating flawlessly, proving that good design can outlast changing trends in tool manufacturing. What makes these tools particularly fascinating is not just their durability, but the culture that develops around them. In many workshops, older tools carry stories. Someone might remember the project where the tool was first used, the job site where it survived a major fall, or the moment when it saved hours of work during a difficult repair. Over time, these machines become symbols of reliability. Newer tools may offer more features or sleeker designs, but the old workhorse sitting in the corner often remains the one people reach for when the job absolutely has to get done. There is something deeply satisfying about using a tool that has already proven itself through years of real-world testing. Part of the reason these legendary tools last so long is that they were designed with maintenance in mind. Many older power tools can be disassembled easily, allowing worn brushes, bearings, or switches to be replaced. This repairability dramatically extends the lifespan of the equipment. Instead of discarding a tool when a small component fails, mechanics can simply replace the worn part and continue using the machine. This philosophy stands in contrast to some modern tools that are built with sealed electronic systems and lightweight components that are difficult or impossible to repair. While modern tools often provide convenience and advanced features, they sometimes sacrifice the long-term durability that defined earlier generations of equipment. Another factor contributing to the longevity of these tools is the quality of materials used in their construction. High-grade steel gears, copper windings in the motors, and durable metal housings allow the internal components to withstand enormous stress. When cheaper materials are used, parts can warp, crack, or wear down much faster. In contrast, well-built tools from reputable manufacturers were often intentionally overbuilt. Engineers designed them to handle workloads far beyond what most users would ever demand. This margin of strength is what allows them to keep operating decades later. Even the weight of older power tools can reveal something about their durability. Many of them are noticeably heavier than their modern counterparts. While that extra weight might seem inconvenient, it often comes from thicker metal parts and stronger internal components. These heavy designs can absorb vibration and resist damage from impacts more effectively than lighter tools. Experienced mechanics often recognize this difference immediately when they pick up a tool. A machine that feels solid and balanced in the hand usually indicates that the manufacturer prioritized durability over minimal weight. Despite the rise of cordless technology and advanced electronics, many professionals still keep at least a few of these legendary tools in their workshops. Cordless tools have revolutionized convenience and portability, but battery systems inevitably wear out over time. Motors and gearboxes may remain functional for years, yet the battery packs often require replacement after repeated charging cycles. Corded tools, on the other hand, avoid this issue entirely. As long as electricity is available, they can run indefinitely. This simple advantage helps explain why certain corded machines continue operating reliably long after their cordless counterparts have been replaced multiple times. Another interesting aspect of these nearly indestructible tools is how they influence purchasing decisions among professionals. Mechanics and contractors often learn about reliable equipment through word of mouth. When someone finds a tool that survives years of abuse without failing, they share that experience with coworkers and friends. Over time, certain models develop legendary reputations. People begin seeking them out specifically because they know those tools have already proven their durability in the real world. This reputation can last for decades, even after newer models are released. In many cases, the most reliable tools were created during a time when manufacturers competed primarily on durability rather than price. Companies understood that professionals depended on their equipment daily, so reliability was a key selling point. A tool that failed frequently would quickly damage a brand's reputation. As a result, manufacturers invested heavily in strong materials, careful engineering, and rigorous testing. The tools that emerged from that philosophy were built not just to perform, but to endure. Today, some manufacturers are beginning to rediscover that philosophy. As consumers grow frustrated with disposable products, there is increasing demand for equipment that can last for many years. A tool that survives decades ultimately provides far greater value than one that needs to be replaced every few seasons. The legendary power tools that refuse to die serve as reminders of what is possible when engineering focuses on longevity rather than short-term cost savings. For mechanics, builders, and craftsmen, these tools represent more than simple machines. They embody the idea that well-designed equipment can become a lifelong companion in the workshop. Long after new models appear with flashy features and redesigned casings, the old reliable tool continues doing exactly what it was built to do. It cuts, drills, grinds, or drives with the same determination it had years ago, proving that true quality doesn't fade with time. In a world where many products are designed to be replaced quickly, these enduring power tools stand as rare examples of engineering that simply refuses to quit. Another reason these legendary power tools continue surviving decade after decade is the philosophy of mechanical tolerance that older engineers followed when designing them. In simple terms, many of these tools were built with wider safety margins inside the motor and drivetrain. The bearings could handle more load than the motor would ever realistically produce. The copper windings inside the motor were thicker than strictly necessary, allowing them to run cooler and resist overheating even when the tool was pushed to its limits. Gear teeth were cut from hardened steel and designed to withstand repeated impacts without chipping or deforming. This meant that even if a tool was abused, dropped on concrete, run for hours continuously, or used for tasks slightly outside its intended purpose, it could survive the stress without catastrophic failure. That kind of over-engineering might seem inefficient in modern manufacturing, but it is exactly what allowed so many of these machines to outlive the people who originally purchased them. In workshops where these tools have been operating for years, they often develop a kind of reputation that borders on myth.